So let's have this sample exercise. Find the confidence interval of the population proportion with the following data. Estimation of population proportion for 99% confidence with a sample size 60 and a point estimate of 8. So let's try to write the given information. We have here 99% confidence. We also have our sample size, which is equal to 60, and the point estimate, which is denoted by this mathematical notation p hat, because the one that you see there, the symbol on top of p looks like a hat, so call it like the p hat or point estimate, which is equal to 0.8. So the point estimate of the population proportion represents the number of successes in n trials. Like say for example, we have if you want to know the population proportion of the working individuals in Cebu City who were positive of COVID-19. So for example, in a random sample of 1,000 working individuals, random sample of 1,000 working individuals in Cebu City, $25 of them were positive. So 25 were positive of COVID-19. Just okay. So if 25 of them were positive of COVID-19, then we represent the point estimate or p hat for this particular case as 25 all over 1,000. So you do the math, 25 divided by 1,000, it's basically 0.025. So this is now the point estimate. Just change the, so this is now the point estimate or the p hat for this particular case. 1,000 working individuals in Cebu City who were in a random sample of 1,000 working individuals in Cebu City. We're looking at the population proportion of them who are positive of COVID-19. So upon testing, 25 of them were positive. So we have this value or point estimate, which is 0.025. So that's basically what the point estimate or p hat is. So it represents the number of successes in n trials. Now, inversely, we have what we call the q hat, which represents the trials that were not successful. So in this case, for 1,000 working individuals in Cebu City, 25 were positive of COVID-19 upon testing. So how many were negative? So we just subtract 1,025. So 975 all over 1,000. So we have here, this is now our q hat. Need to know this because this is going to be part of the formula, in the formula that we're going to use to look for the confidence interval of the population proportion. So that's 0.975. Okay, so p hat, q hat. Now let's proceed to what is being asked in the problem. So 99% confidence with the sample size 60 and point estimate 0.8. So here, what's going to be our q hat in this case? If p hat is 0.8, so basically our q hat is just 0.2. Again, this is a population proportion, so both the q hat and p hat, if you're going to add them, it should equate to 1. Okay, so the formula for, let me just write the formula for the q hat. Q hat formula is just 1 minus p hat. Okay, now let's proceed to to the formula. So the formula here for to find the confidence interval of the population proportion is we have here p hat plus minus our z sub alpha over 2. Then we have here the square root of p hat and square root of the product of p hat and q hat all over our sample size n. Now we have p hat, we have q hat, we have the n, but we don't have this yet. So we're going to look for this. Okay, this is what we're going to look for. Z sub alpha over 2. So how do we find this? We just need our z table for this. So let me just, so alpha here, by the way, is so let me just quickly. So alpha in this case, how do we find alpha? It's just equal to 1 minus our how do you call this one? Confidence. The given, like in this case, we have 99% confidence. So 1 minus 0.99. So that's our alpha. Okay. So 1 minus 0.99. So that's basically 0.01 for this sample exercise. Now, next is, since we have alpha over 2 is going to be equal to, so alpha over 2 is going to be equal alpha over 2, so 0.01 divided by 2. So that's basically, so in this case, let me just check. So that's 1, 2, 3. So that's 0.005. That's our alpha divided by 2. So what's going to be next here is we have to, in the z table, you have this. Let me just illustrate quickly. In the normal distribution curve, it's going to look like this. So this is our normal distribution curve, and since this is alpha over 2, so basically there are two values that are involved. One is below the mean, or the left side of the mean. So from here going there, the left, going to the left, and from the mean to the above it, or going to the right. So 0.005 is going to be somewhere here. That's going to, and also somewhere there. Sorry. Okay, then there you go. Now, so that's our 0.005, and these are 0.005 on both sides. Okay, now we are going to look for the z-score that represents, because this is like z all over, I mean z sub alpha over 2. So the z-score that represents the area that I've shaded with the blue. So to find that area, we just have to know this already. I think you had this before. So this whole area, that's basically 0.5, right? From the center all the way to the left, that's 0.5, and also from the center all the way to the, this is also 0.5. The whole area is 0.5. Okay, let me just, so for a while. Okay, so this whole area, let me just, okay, the whole area, that's 0.5. 0.5. So to find the z-score that represents the area shaded with blue, you just have to subtract 0.5 by 0.005. So here we have 0, 0.5 minus 0.005. So that's basically, this is equal to, just use your calculator to do the math. So we have 0.4950. Now, in the z table, we have to look for 0.4950 in this case. So let's go to the z table. Where's that? So here, it's here in the z table. 0.4950 is, it's not in the z table, but the closest is we have 0.4949 and 0.4951. 0.494, no, let me do this. Let's add the image so that it's easier to locate. Photo library, let's go, no, cancel, let's have this again. Here is the z table. We have the z table here, so let's wait for it to be uploaded. Okay, so after this, if we will be able to get already the value of our z-score, z sub alpha over 2, then we're good to go for us to be able to find the confidence interval of the population proportions. So for this particular case, it took us a while because this is like an introduction of doing a lot of explanation in terms of introducing the concept of population proportion. So, but later on your own, you can do this quickly. So let me just highlight so again, we're looking for oh no. Okay, let me just do this. So since we're trying to look for 0.4950, the closest is this one. There are two values that have the same difference from 0.4950, and that's 0.4949 and 0.4951. This one. So if you're going to look at the value, the z-score that represents both areas, we have 2.57 and 2.58. So in this case, if you have the difference from the area that we're looking for this case 0.4950, if the difference of the areas that you have there in the z table is the same, then we have to find the z-score by interpolation. We add both z-scores and we divide it by 2. So let's do this. So we have 2.57. So 2.57 plus 2.58 all over 2. Okay, so here this is going to be 2.575. So that's the z-score that we're going to use in the formula. So I hope you got it. But the rule of thumb, you just have to locate the how do I call this one, the closest area to what we're trying to look for, because in most cases the areas that we're going to look for in the z table will not be always there. Okay, so the closest, but in this case, since there are two areas that have the same difference or same distance from 0.4950, that's why we're um, computing the z-score via interpolation. So we add both z-scores and divide it by 2. Now let's go and continue. We have, let's use now the formula. We have everything already. So in this case, so let's have p hat. So just put a line here. I'm going to make it smaller. Okay, let me just put a line here. So and a line here. Okay, so p hat plus z all over c sub alpha over 2, and we have here times p hat and q hat all over n. Okay, all over n. So let's just substitute the values. We have 0.8 plus 2.575. Then we have here our square root of p hat, which is 0.8 times 0.2, and our n here, sample size is 60. Okay, so basically if you do the math there, let's try to, okay, please use your calculators, and you can verify this also. So we have, let me just do this quickly. So we have there, okay, 0.93 9329. So 0. So we have here 0. Oh no, it's not working. We have here 0.9329, or in percent, it's approximately 93%. Okay, percent. Now let's look for the other value, which is going to be p hat minus, this time, z alpha over 2. Then we have here square root of p hat times q hat all over n. Now let's just substitute the values. We have 0.8 and minus 2.575. Then we have here square root of 0.8 and 0.2 and all over 60. So let's do the math. You can make use of the ones that you already have inputted in your calculator, and just change it from plus to minus. So this is equal to 0.6670. Okay, or approximately you have 67%. So now we have our confidence interval. So we go back to the question, estimation of the population proportion for a 99% confidence with a sample size of n, which is equal to 60, and a point estimate of 8 is would lie between 67% to 93%. So this is our final answer, and we're done. And that's it. Thank you so much.